Hello, everybody. Yeah, thanks for coming here. Join me with a speech about machine learning. Uh, my name is Tom. I'm software consultant. I'm working at Farm Credit Service of America right now as like a contractor. It lasts like 3 or 4 years. Today, I would like to talk about like machine learning. The purpose is like give an overview about like what is it, and then how to solve the machine learning problems. So really, like recent years, I heard a lot about machine learning. I heard a lot about like big data, about AI, but then it's like triggered my curiosity like about what is it, and then I mean how to solve it, how to recognize a machine learning problem, and how to solve it, like what it does, what can machine learning help us in our daily work. So at first, whoever like among us like used to work on a real machine learning project? So okay, 0. So whoever like research, like have an interest, know about it, understand like overview, what kind of machine learning? Can you raise the hands? Yep, we got some. So really, the purpose today is like there's no need for like knowing anything like in advance. So it'll be like from scratch, and this is like overview. So it's nothing special. So first of all, what is a machine learning problem? So when talk about machine learning, we need to be able to answer like, is that problem a machine learning problem, or is that not a machine learning problem? For example, if I ask a question like, I need a website with the authentication log, like the username and password login, is it a machine learning problem? Or if I ask another question like, when I open YouTube and then I see some suggestion, I see a lot of like video showed up on my screen, is that a machine learning problem? So sort of question that we need to answer. So the first one, I would talk about the navigation, like the map, like the Bing, the Google Map, right? So when I just took a map from my office to here, and then I type Google Map, I put it like my Farm Credit and then Blue Cross Blue Shield. I got the time like 16 minutes. So then I started leaving my office at 5:30. So is that a machine learning solution? I guess the answer is yes. We will talk about that later. Another one is like a trading, right? So today is like when you trade the stock, right? Today is an up day or a down day. So we want to know that answer, right? Why? Obviously, I mean, if you know this is an up day, then we gotta buy, right? Then this is down day, okay, we sell. So this is fairly important question. Next will be like a sales forecasting. So we want to know like next month, how is the sale look like? Or we want to know like in the retail office like Walmart or Target, we want to know like in the next month, how much the demands look like, how many like this kind of products likely to be like consumed. Why that's important? So we can stock enough the products to sell, right? To get more revenue. Then a human, I mean, so we can recognize the voice, whatever. So when somebody talk on the phone, we need to know, hey, that's it the male or the females. And then when we understand the person on the phone, for example, then we can handle their question. The conversation with them will be like better. So spam or not spam, is that a machine learning problem? Why is that?
Because spammers getting really tricky about how they would put an email to attract your attention. So you need to have a better system to recognize that it's actually spam, especially if it's not something that obvious. Wow.
Yep. So I mean, like 5 years ago, I used Google Mail, and then all of the email used to be come like straight to my inbox. But then all of a sudden, Google have like some tab, like mail and then something else, like social, promotion, product, something, right? And then automatically they filtered those emails to some categorized. I think those are machine learning solution. How about credit card transaction? So last week I purchased some, actually my wife purchased something at Walmart, and then all of a sudden I got a phone call from Citibank, which is my credit card company. Say, hey, there's something with that happening. Can you? And then they blocked my card. So that example seems to be like a machine learning solution, and that call is bad. I don't expect that call because this was my wife who like swiped the card. So machine learning actually give me problems. It's trying to help me, but many times it doesn't. The customer, we want to know if the customer like intend to move to another competitors or not, right? So how over the phone, how do we recognize that customer is not happy with us? Based on what? So obviously if they say, yeah, you are not good, I'm going to move, then obviously we knew it, right? But then if they don't say anything like bad, they say, yep, it's good. You say, how is our service? What do you think? Any feedback? I say, no, I don't have feedback. I say, good, bye-bye. So like those things, are they happy or not? We need to know, right? And I think machine learning can help us. Ad or non-ads, YouTube, video, movie, recommendations, Netflix. So when I click something, when I create an account in Netflix, and I put like my preference, I put my interest there, automatically like when I go to my like profile, I see like a bunch of movie that I really like. I was like, how can I get this? So I think it's machine learning in the background. So then those problems, machine learning like trying to solve the problem for us. So are those problems important? Yep, it may be, but it may give me troubles. It may block my credit card. So next will be why machine learning is important. So first of all, we just saw the problems, right? The domain problems, and we see those problems are important. If we have a solution, it will be a good help for us, for our work, for our business. But then why is it like really important? Really, the problem is important. But then if we don't have the reality to solve it, if we don't have the capable of solving it, then okay, I know that's problem, but I'm not gonna solve it because I don't have ability to solve it. But these days, machine learning is important because we have a lot of data. So imagine like a credit card company, like a day, how many transactions they have, or like the cell phone company, right? How many like data, how many phone calls they have in their database like in a day. So with those data, how can we utilize those data to help us? That answer this question. We have a lot of data. We have we are in big data area right now. So that may trigger something like, okay, machine learning may be one of the things that the business leader may think about it, or developers, or anybody who interested. Second thing will be, we have a lot of computer powers. So let's imagine we have like 10 years ago, 20 years ago, we have like a tons of like phone call database in database. But computer is so slow. We're not able to like compute anything from those like image or video or like big binary data. So these days, with more and more computer hardware is developing, we have supercomputer is developing as well. It's become reality with machine learning. Also, we have machine learning algorithm. We have effective. So the researchers are working really hard on machine learning area, and they have more and more algorithms to help us to process the data the way that we want. So they are producing more and more algorithms that help us. So with those things, I think this one is the most important thing. So the big vendors, they started thinking about like, hey, this is reality now. So when the big vendors think about it, they will put more money on this industry. I already know like Amazon, Microsoft, and Google put a lot of money in this industry. Netflix already there, right? Amazon. So they, when you go Amazon website, you buy something, then they will suggest you some similar products. So where is it coming from? So they know the value of machine learning. They know the value of the data they have. So they started thinking, okay, this is possible, and they want to invest on that. I mean, we cannot do anything with our business, right? So if the vendor, if the guy is not interested to put the data down, put the money down, then I mean, there's no money, then nobody like moving forward. Yep, those points make machine learning possible. And then really, here I mean, I learned the code from I mean somebody that I learned that the machine learning may help your organization. It's like it can help, but it may not. Like in my case, it blocked my credit card, and I got angry. So then, and they blocked my credit card like not once, 3 times. Yeah, I called it, say, hey, I'm good. Please release it for me, unlock, and then second time they lock it again. They try to be smart. So then, who get involved in machine learning solution? Can somebody tell me, like, who will be interested in machine learning in our work here? So when we think about machine learning, right, who will really dig deeper in machine learning, I mean, area? You say what?
Big brother.
Governor?
Surveillance.
Surveillance. So obviously, like us developers, why we're interested? It's a job, right? I mean, we work. We are developer. We can develop a machine learning solution, right? We can apply if in resume we have okay machine learning knowledge, right? Skills. Then is it like this is the big vendors already put the money down there. Then they need people. So we are as developer, we will be interested. Who else?
Doctors, medicine.
Doctor, medicine. So those are like consumer. Those are like a kind of a user of the machine learning, right?
Basically, assistant.
Right. So we have a ton of user. They like the machine learning solution, and they will pay the money to have that, right? So they are kind of like business owner. So think about, hey, I want that solution. So then they will put a contract to the company, right? Then, hey, I want that solution. Can you implement that for me? And then they sign a contract. Okay, they put money down to have it. So this is the business owner. Now, who else?
Consumer.
Yes, consumer, they like it, right? They use it every day now. I mean, I watch Netflix, I watch YouTube every day. There's one very important person, which is, now we got business owner, right? We got developers. Now the last person is one of the most important person in machine learning, which is data scientists. So when talk about machine learning, we are talking about data. Like we have tons of data, a big amount of data. We need somebody. I mean, developer is a person who writes the software, but he's not writing the algorithm. The algorithm was there. So I will explain more about the process of solving the ML problems. Developer is not the important guy. So the most important guy is the data scientist, because they need to understand the data. So the raw data is really like, there's no format at all. It's not clear like what is that data means. So on the phone, people ask you, do you like our service? You say, yep. You say, yup, what does it mean? So somebody needs to like listen to that and then determine like, do you like it or not? That guy is a data scientist who really expert about data. So in a machine learning solution, we need that guy. So if we have the intention to develop a machine learning solution, if I am the business owner, the first person I would think about is I will look for that guy to be in my team. Developers, really maybe not important here. Second importance. Actually, the business owner is the most important person, right? It's the money. Where's the money coming from? So when we need to use machine learning, difficult for human to express the rules. What does it mean? So if I put in Google Maps, I want to go from Farm Credit to Blue Cross Blue Shield, and it's showing me 16 minutes. Where is that 16 minutes coming from? So if I am developer to develop that system, the first approach that I will think about, hey, from here to there, how can I calculate those, the minutes, right? How can I calculate how long it takes me to go there? I would think about like distance. How far is it? And then today is Thursday. Thursday is different than Sunday. Maybe Thursday is more people. And today at this time is like 5:30. I mean, people are going home, maybe traffic jam. So like 5 p.m., 5:30, I will think about, okay, what time, what day, how far is it? How is the weather? Is it like snowing? Is it like it's rainy? I have to think about those, a lot of conditions. So if I am if I'm a developer, right, I write that algorithm, I will ask the business owner, hey, what is the rules? Give me the rule and I'll program it. Nobody can answer that. It's like, it's very hard for human to express the rules. And the rule is like changing, right? So I mean, every condition is different. And what kind of car that I'm driving? I'm driving a bicycle or a car or like airplanes, right? Those, a lot of like rules there. So it's difficult, or it's like impossible for human to express, to write out the logic. So that's where we need machine learning. All right. What else? What is the other, like, I mean, condition that we need machine learning?
A lot of rules.
A lot of rules. Okay. We have data. Data. Yep. Data is very important. Without data, we say like, hey, we don't have data. There you go. A large amount of historical data. So really, like when I go to my office to here, the way I'm looking at that is, okay, I look at the history data. So like every single person, right, go from here to there. I say, okay, how much this take this guy to go from here to here. I'll say, okay, this guy take 20 minutes. Another guy take like 15. Another guy take 10. Another guy take like 17. What about I like average those information and I have 16? What about that? It's a lot of the other day, right? What about I have, so I just like give example of like 5 examples. What about I have 5,000 examples of like 5,000 guys go from my office to here, then I take an average of that. 5 million times. Still? All right. So we need a history data with a large amount of data. It will help. So when we have that in our system, we may start thinking about machine learning. Patterns. So the patterns are dynamic. Like it's exactly the example that we are talking. Like Is it like going this route or go this route, or like what is the weather, what is the time, is it traffic jam or not, is it like bicycle or airplane or like car? Those patterns are like dynamic, so we don't have the fixed pattern. So with those things, I think it's a good chance to think about machine learning. Same thing here. So the first approach is the rule based on the left. That we're trying to like define like what kind of rules we have. Those rules are really like static and really hard to change. And if every time we want to change, we want to add more rules, then we need some sort of like analyze it. Because like we don't know about that issue. We don't know about like, is those rules are enough? So we need some kind of like analysis scientist or somebody who know about the domain to tell us more about the rules so that developer can program it. Vice versa, in the machine learning base, we collect the amount of data. 5 guys, take the average. Maybe not accurate. 10 guys, 10,000, 5,000. Every day, I mean, there's a lot of traffic from there to here. So really the rules are dynamic, right? So we understand the difference between the rule-based and the machine learning base. When do we need it? Why it is important? When do we think about machine learning? We need the data, we need the rules. That's very hard to write it down and then list it out. So those kind of like the sign that we may think about machine learning. And then if we think about machine learning, then we started thinking about who will be working on this project. It will be like, okay, developers, I need developers, I need data scientists. I think 2 persons is enough. 2 group of person. We need QA as well. All right, so this is the kind of recap. The rule-based approach and the machine-based approach. Any questions so far? Cool. Here is kind of like the overview about the machine learning process. So when we talk about it, what is the components in our process? So data is the first block, which is really important. And then the algorithm, and then the model. So 3 parts: data, algorithm, and model. The application will use the model. So model is something, when we say model, it's really like executable file, like the outcome. Then the application just call it like, this is the guy, this is the machine. Say, then the application will ask him a question, like, hey, give me that, what about that, what about that? And that model is like a machine. It will return the answer for the application. And then the user will look at the application and do some business. So that's the model. The data. So is it like any kind of data? No. The data need to have a pattern. Where is the pattern coming from? So if I make a phone call to somebody, right? Hey, dude, how are you? I want something from you. And then obviously that conversation will be stored at my provider, right? They keep that data. So is that a data that can help in machine learning? Yes and no. So the raw data is really rough. So we are not able to do anything with raw data. We need to have the processing to like process the data in the way that the algorithm will understand it. So again, we have data, we have algorithm to combine to have the model. But then the data need to be processed in the way that the algorithm understands it. So if we are developing an ML system, we need to understand the algorithm, right? We need to know the capability of like how many options of the algorithm we have. We are not developing the algorithm. They are developed already by scientists, by some other company, by somebody like interest. They develop the whole thing. Well, we can do a funding to develop our own algorithm, right? Because they do that, we can do that as well. But really in the industry part, when we're talking about 2 sides, the scientists and the industry, in the industry, we just use those algorithms. It's like Visual Studio, right? We are using Visual Studio to make the code, to make to make an application. We can fund to rewrite a Visual Studio if we want, but it's there. Microsoft did that. Now, those algorithms is the same. It is like pre-developed by somebody, some scientists. They spend tons of time doing that. Now, we need to understand that in order to prepare the data, the data that those algorithms understand, to combine that to make a model. So, really in this process, what is the most important part to us? Like in this picture, data, machine learning, or the model. So when we develop an application, when we create a team, right, to work on this machine learning problems, what will be the most, I mean, we will spend the time, the most of the time in where? Here. Here, because this we already have. We need to have this. And the data is value. So some company, they need to buy the data from, I mean, this is the industry to sell the data. And then they got the raw data, they need to process the data the way that they want. So this is where our team, we spend a lot of time. That's why we need data scientists. So developer will be like taking this data, hook up with this to build a model. All right, next. First of all, if we starting like develop a machine learning problem like solution, we need to be able to ask the right question. So what is the problem we are trying to solve? What is the question we want to ask? Because those questions will be, we will build the model, right? We will build like the guy, the robot, or like the machine. But then we need to define what kind of question we will ask him. So if we ask him something like irrelevant, he'll like, I don't know, right? So we need to prepare the question. What kind of question is it? Today is the up day or the down day, right? That's one question. Another question may be how long it takes me to go to my office to here. That's a question. So we need to have a good question. And then next we will say, do we have the data to answer that question? So I mean, we are like at the early of like machine learning to create a machine learning solution, right? We found a team, we're looking for hiring some developers, some data scientists. Then we need to answer those questions. Do we have the data to solve that? If not, then what's the point? Think about it. If we don't have data, then what's the point of like talking about machine learning? So, and then the final one is very important. Can somebody like make a guess? So in the project, here's a question I want to challenge you. In the machine learning problem, right? We are building a team to work on a machine learning. We want to make a solution. So we need that. We need that. And we need what? To guarantee that our project will be a success.
Output.
We need an output.
You're right.
Good. We need an output, right? But then what kind of output? What is the expectation on that output?
Correct. Answer. Payroll.
So let's say I built the whole thing, right? So I got the money from business owner. She gave me like $1 million. I hired some bunch of guys working with me. After 6 months, I give her like a robot, like a machine. And then she started asking questions. Obviously, those questions was like, we contract with her, right? Hey, you gotta ask those questions. You are not allowed to ask other questions. So then she will ask those questions. So like, this credit card transaction is a fraud or not? She will constantly ask that question. Like my wife make a budget, right? And then the question is that a fraud? Then another day she make a purchase, like, is that a fraud? So that constantly question, how many, obviously in my case it's wrong, it failed, right? So how many like percentage of the correct, accurate answer will be acceptable? What is the expectation, like how smart is it we want? If we don't specify that, we gotta fail the project, and I couldn't get like $1 million. So the expectation of the machine learning, like the model, is important. Okay, so this is kind of like a content of the process of machine learning. First of all, we need to pick the problems, and then we need the data, and then we need to apply the algorithm, right, that we know about it. Now, the next thing is more interesting. So, raw data. In here, we have raw data, and then we process the data. Are we processing like one time only? Are we? So this is the good of machine learning, because we have a ton of data, right? Every day we can reprocessing that. We can keep making the data like more accurate, making it better and better every day. We can remove some duplicate data. We can correct it the way that we want, and then some. And time by time, I mean, it's changing. The pattern is changing. It's dynamic. So people today, I mean, most of the time from my office to here, it will be like car, right? Car. Maybe 10 years from now, it will be like driving helicopter. So it's changing. So if we don't have that ability, then this guy will build a model, and this guy will be a stupid guy. Okay, I mean, he couldn't like keep up with the changing of the pattern. But if we do this, like reprocessing, applied reprocessing algorithm, then our model will be like teaching. We keep teaching him about the update, and he'll be keep up with the real current data. The same thing, when we apply the algorithm and then deploy to get a model, like the whole process will be like a circle. It's happened like every day. So the machine can learn themselves to make it more smart. So that's a good part of machine learning. We don't teach him like a static logic, and then he stay there, he function the static way every day. Any question on this? Okay. Now, talk about the problem. So we have 4 kind of problems. So really, let's step back. Why pick the problem is important? Yes, we need to know what we want. So, like I said at the beginning, we have a tons of like algorithm already developed, right? So if we don't know our problems, how can we know what algorithm is the solution to our problems, right? So they have some sort of like, they categorize those machine learning problems A, B, C, D. So for A, they have this kind of algorithm. So for A, they have this algorithm. For B, this algorithm. For C, they have this algorithm. So that gives us the guideline. Like when I have an issue, when I have the problem, I need to describe my problems in the way that, okay, this problem is belong to classification. What does classification mean? Really, is it the label of like one or the other? Like, is it an up day or a down day? Is it like a spam or not spam? Kind of thing. So A or B. So when I have the problems like A or B, I know this is classification category. And then when it's a classification, I will like search, right? I say Google, what is the algorithm for classification email? And then I will have like some choice here. And then I just use it and applied it. Same thing here with regression. Regression basically like it's more than A or B. So it's a little more variations. So what is a stock what is a stock return like in next week? So it makes prediction. And then it's kind of like harder question, right? And then how the customer will be affected if we change something, if we change this policy, how is the customer gonna react? So those kind of question is a little more variables. There are more variables that fit into the system. Clustering will be similar with regression, but clustering is more about we group the same things together. For example, in this team, in this room, right, we want to group a group of people into a different cluster based on whatever category, like let's say based on age, or based on gender, or based on the interest, right? Somebody like kind of that movie, then go to one group, and then the other group will be okay. So based on the categories that we can group those different people in a different way. So those are kind of like a clustering problems. And the last one is the recommendation. We talked about it already. So when I go to LinkedIn, I look at one person, and then they're on the right, I see, okay, these are the other person you may want to look. You may make friends. So kind of suggestion, recommendation. So why this is important? Again, it's important for us to categorize our issues belong to which one. And then when we know that, we will have an ideas about what kind of algorithm we will do. We will like apply. Any questions? Okay. So this talk more about classification and regression. So the classification is basically categorical the output like A or B, and the other one is a continuous output. Like what will be the stock value of the next week? So I want to buy. So I hope I can build a machine like that. If I have a lot of data, right? So really, that's what the finance people they do that. They have the data. So have you heard about like black box trading? So really, I mean, they use a lot of like machine learning algorithm to keep track like what is the data, the trading data of a specific stock number in the last week, last month, the last 3 months, last 6 months, last year, last 5 years, last 10 years. And then they do like black box trading. They have a robot to like check every single stock, and then they can predict that, okay, with this trend, what is gonna look like in the next day. And then it will give the and it will automatically buy or sells. So, and that's the way that so we have a lot of like financial advisor, because we don't have data. They do. So they have the software, which is very expensive license, and they subscribe to that software, and then they open an account for us. We come to see the finance advisor. We put like 100,000. Hey, this is my 100,000. Can you invest that for me? Really, he does nothing. He just like take our money and put that into the black box trading system, and then he just like open an account. He will like hire like some consultant like us to create a website with the account, right? And then in the back end, he just take our money and then put it there, and then he do nothing. And then get some interest from us. If we lost, then he say, "Yep, sorry." But if we got profit, then he takes some. So it sounds like a good job, right? All right. Same thing here. I already talked about it. So here I list some algorithm. naive-Bayes, support vector machine, linear regression, k-means. So those are the known algorithms. They already developed. We just use it. So we're not investing in the new algorithm. We don't have time. We don't have money. We don't have fun to invest in new Visual Studio. So we just use it. But in order to use it, again, we need to massage the data in the way that those algorithms understand. So massage the data is important. Okay. We will take one. So here we have like a bunch of algorithms, right? So like naive-Bayes, something here. We'll take one and then work through the process to see if it makes sense or not. So let's say we have a problem. The problem will be, I got a comment from the team here. So the team here may say, hey, Tom, I'm sleepy. Or the team here will say, yeah. So I got a comment. I need to know, is it positive comment or is it negative comment? Or I may look at the face of somebody and say, okay, yeah, I know if that person is interested or not. So I have the problems. My problem is, I want to know the comment is positive or negative. That's my problem. That problem belongs to what category? We have 1, 2, 3, 4. So it belongs to the first one because I want to know like yes or no, positive or negative. It's classified. So I need to build a machine that can answer the question like positive or negative. I will constantly ask him that question with the input like, yeah, I'm sleepy. That's great. It's fun. Just those questions, right? I want the machine to be able to answer that. Now I know my category. I know it belongs here. So I have two choices: the naive-Bayes and the support vector machine. I have two algorithms for me to pick. Let's say I pick the first one. So what do I do? What do I like started doing? So I say what? This is the process, like problem statement. I just declare my problems. I want that. I want to answer that question. The next thing will be, oh yeah, this is the problem statement, right? We just talked about it. So the next thing will be the features. So in here, you said problem statement, then feature and training and test. So now this is problem statement. The next will be features. So what is the feature that I'm looking for? So I'm looking for like a data. Again, at the beginning, we have the data, the big box is the data, the algorithm, right? And then the model. So the whole thing here, I'm talking about data. So let's say I have text number 1 is positive, which means like, if I hear something like, yeah, that means positive. Let's say, okay, negative, right? Right? Yes. Okay, like this, mean positive. Okay.
Sometimes you're right, doesn't mean positive.
I told you like how many percent you accept the answer correct is a success, right? So now I have like 100 of text, and then I have every text I need to define. I need a data scientist, right? Here I need a data scientist. He needs to like he needs to like write down. If you say like this, is it positive? He needs to give me that definition. Or I say yeah, with a yeah mean positive, with a yeah mean negative, right? So I need that data. Data scientist will give me this. Now, that data will become a tuple. This, don't worry about that much. This is the way that the algorithm will understand. So we are, as a developer, well, the algorithm should support us the way to translate this to this. Depends, right? We can do a lot of work on this, or if the algorithm is nice, then they will help us on that. So here is the phase that we spend a lot of time in machine learning. I would say like more than 80% of time, effort, money. So then, whatever there, we don't need to care about the work, right? What we knew is a text translate to a tuples. And then those data here is the training data that the algorithm gonna understand it. So that phase is the feature. So we sit down, we feature the condition, the meaning of the data. So to build the training data. So now we are moving to the training phase. That is more something about the algorithm, right? So the algorithm expects something. So at this point, I need to research. I mean, I should already research the previous point about like, okay, write down the text is positive or negative. And then in here, I need to know, okay, what is the algorithm doing? So really, if I get a random text like, the probability of the positive will be like, let's say PO. Then the probability of the negative will be like 1 minus PO, right? So if I ask you a question like, you like my presentation or not? It will either like yes or no. So the probability will be like PO, or the negative will be like 1 minus PO. Because the sum gotta be 1. I mean, unless somebody doesn't answer. If I don't get the answer, then I will remove this from my data set. You don't answer, right? So there's no point to bring it here. So, so this is like the way that, so let's say if I say the food. So the POS here will be like the possibility of like the positive. It will be like the sum of the positive divided by the sum of all of the comments, right? Make sense? So if I ask all of the people in the room here, like, are you sleepy? Then I know, okay, I can count, right? We have like 35 people here. I know 35, so this one will be 35. And then I ask the question, are you sleepy? Then you say, some of them will say, son, yeah. Some of them will say no. Somebody like close their eyes, so I know he's sleepy. So if I say like, if I got like 15% say yes, right? then I got what I need, right? So then on the other hand, the negative will be like 1 minus POS. So we have two concepts: the POS, the positive, and the negative. Now, yeah, that is the outcome. I will save those outcomes into like a table. Like, are you happy? You love, food, hate, bad, with the percentage. So that is the training phase that I'm gonna to collect those kind of data. Still, this phase, I don't need to be a developer. Is it data scientist? They do it. Of course, I need to transfer the data scientists, whatever the outcome. Well, I think this one could be developers, right? Because, I mean, I can write on, this is the algorithm that, I don't know if data scientists can do that. Maybe not. So, all right, now we move to the test phase. So really, let me go back, right? We said training phase, features. So what I'm so far is the problem statement. So problem, feature, training, and then finally the test. What is the test phase doing? So I have, all of my work so far is like I get up like, okay, love 60%, sleepy 10%, well actually 40%, alert like 3%. So all of the work that I have done so far within like months, I got those data. Then I need to test it. How? The test actually apply the algorithm, which is the easiest, the easiest step in the whole process. Because I got the algorithm, I just apply those data to the algorithm, and I got a robot. So, all right, training, I got the data there. Now test. So, if I have the comment like I like book, is it a negative or is it a positive? Right? The question still at the beginning was like, is it positive or negative? Positive or negative? negative or positive. Now I got a comment like, I like book. So I ask all of you guys here, say, hey, did you like my presentation? I would expect like yes or no, right? But then I got the answer, I like book. Okay? So I want to know, I like book. Is it like a negative answer or is it a positive answer? Okay, here's something. I like book. The way that the naive-Bayes algorithm will do is this. So they take every single word like independently. So they take I, they take like, they take book. Obviously, I mean, they can remove it, right? They won't consider that. It's like subject. So they say, it's not something so data scientists will tell me to not consider some word, right? And then here we like and the book. So I will take the possibility of of like and book and overall positive. The overall positive is something like an average. Just take an average of the whole thing. And then say, okay, that time that, I will have the positive of the comments, right? And then the negative of that comment will be obviously like 1 minus that times 1 minus that times 1 minus that, because we already talked about like this is A or B, right? A or B, like the like will be like A or B. Is it a positive or negative? The book is negative or positive. So then theoretically I can have those two numbers. If I ask all of the question of another person here, right, I will have that value. Okay. If I got that like the positive is like 0.7 and the negative is 0.4, which obviously I can do that with the data set I have. What does it mean? It means positive. Why? I mean, yeah, 0.7 is greater than 0.4. So I got a possibility of positive is higher than the possibility of negative. So I will say, I like book is positive. Although I'm stupid, but that's the way that the algorithm is working. And if it gets a ton of data, the more data it has, the more accurate answer they got. All right, so now we applied it. So this basically the algorithm that they do. It's just, so the demo here is just for us to understand how it works. And then in the real world, right, it'll be like this. It'll be easy. So it'll be like, hey, this is the data set. I will ask a question like, is it the comments to my presentations is a positive or negative, right? I mean, after this, I will do a survey. Every single person, right? Brian will ask a survey to every single email. And then the question will be like, did you like my presentation? All right, now I got like waste time. Waste time, this is my data set. So if somebody return waste time, this is like 0. 0 mean negative. And somebody say, appreciate it, which means positive. So this will be the data set. Where is that data set coming from? So maybe somebody don't reply like waste time or appreciate. They will reply like, I like book. So there will be, so Brian say, hey, dear Ahmad, did you like the presentation, Tom presentation today? Ahmad will reply like, I like book. The way that the human thinking, he doesn't like it. Because he should say, I like your presentation. But he said, I like book, that means he want to read book more than here. So I don't know. So we need to have the data processing process to convert I like book to be like a data, to be like, if I say I like book, in our example we walk through, right? We got it positive, right? So if Ahmad reply like I like book, I will mark it like 1. So this is the data set that I have after like processing the raw data. Those data set will be applied to the algorithm. So in here, the point is, If you give the algorithm the raw data, it doesn't understand. It's like, what? So we need to give it in the format that the algorithm is expecting. All right, so next, the algorithm does is really simple. Open the file. Obviously, we have the file, right? We have the data processing. That data processing will dump the ton of data into the CSV file or the text file or whatever database. And then we need to read that into the memory. So anybody doesn't know how to open the file in Python? In Python. So programming language, I haven't talked about it. So what kind of programming language that support ML? So R is the most popular one. They have a lot of like library. They have a lot of like algorithm already to support ML. Python is getting more popularity now, right? So it's also depend on programming language. Can we do it in C#? I don't know. Maybe not. So I mean, look at C#, right? Does C# have the library? Does C# have the algorithms to support ML? That's a question I will ask. So probably no. I mean, I never heard anybody say yes. Well, I don't know. I know R and Python, they are very popular. They're powerful.
Microsoft owns CMTK is in Python.
Okay. So the process is open the file, right? We know how to do that. We have developer in our team, right? Open the file, writing some commands, some R or Python, open the file. And then we do what? Split the data into whatever like lines, into the array. Easy, right? With that data, we can easily split the data into an array, right? What kind of arrays? Array of like the text, and then array of the labels, right? The text here like waste time, appreciate. The label will be like negative or positive. So we can easily like split the data into two array. One array of like the text, and the other is the labels, true, false. Now, next step will be we will do the transfer. So the third step will be the transfer. The library only do that. The algorithm do that. We say, hey, dot transfer, and then we pass in that array. So we get back another array, right? We get back the training documents array, and then we say this blah 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 dot fit with that training, the train docs and the train label. So what I'm trying to say is this is syntax. So we read the data from the file, split it in arrays. We say transfer, and then we say fit. This is the library. This is the naive Bayes algorithm. So this is on syntax. We don't, as developer, we don't do anything. We're not developing this guy. We use it, and then we get back. What is it? The classifier. This is the model. This is the robot that will answer our question. We're done. So with that, we're done. So developer will get paid really less in this job. Data scientists get paid more. Now, it's a time to test it, right? You say, this is the best, which means, okay, if we say, hey, predict, this is the best, it will return like positive if it's worked like accurately. And then, hey, I feel good, it will return positive. I say, I like book, it will return positive. 0.7 is greater than 0.4. Any questions so far? All right. So really, in this process, right, developers, not good. They don't get paid well. Yeah. Developer need to find a way to get more money in this. So maybe developer need to learn about data scientists. They need to learn math. Or, okay. All right, next. This is about improve the model, right? We kind of talked about it already. So when we found something, so my credit card company blocked my card. I called them. I said, hey, dude, you are wrong. stop doing that. This is my wife who's drive the car. Then I say, yeah, how do I know? Sorry, sir. This is the system. We have no idea. So let me unblock you. And I tell him like, can you somehow like mark it? Like if that happen again, then don't block it. He said, yeah, I will do it. And then the second time, they block me again. So 3 times. That means there's something that is not like learning, right? Obviously, my wife swiped the card in another zip code. So we live in Omaha, and she came to the Walmart at La Vista. So it was so smart, so alert. Say, hey, you are here, you're supposed to go to this Walmart. Right? You have kids, right? I mean, the kids need to go to the school in local, right? You're not about like cross the boundary for another school district, right? So the same thing, the same algorithm. If you are here, we have Walmart here, you are supposed to go to this Walmart. If you go to another Walmart, block. Okay. So in that case, the algorithm need to be improved because there's something wrong. I mean, if I call the second time and they block me, the third time they still block. If the fourth time happen, I close the credit card because hey, you don't improve. All right. Maybe the last slide that I want to talk is at the machine learning working along with other technologies like AI, big data. How is that work look like? So think about like the customer calling to the call center, and on the phone, the call center will know right away is this customer is unhappy or not, or is this customer is about like to move to another competitor. How is that? How is the solution that help the call center staff realize in real time right away, right? Because we're on the phone, right? On the phone is the pressure. Their customer calling, right? And they may talk about, hey, I ordered the product like 2 days ago. Why it's not arrived yet? Kind of thing. So really here, this is the machine. This is the model. This is kind of a robot, right? So we need the call center staff need the way to answer the question like, is this customer happy or not? Is this customer happy or not? If the answer is yes, okay, go ahead and like talk freely with him. If it's no, then maybe they need to be ready to offer something good to this customer. Now, how do they know that information? It is a whole process here. Let's say they have like a bunch of like call center data, right? The call, right? A lot of call data, binary, video, whatever, text. They need to have some sort of like big data here, aggregate the call center, the call data, to have the aggregation application here, and then they may combine with CAM data, the data for machine learning. They have some Hadoop, Spark, so on, kind of like the big data in here. That combined with the CAM data here, right? The data for machine learning. It will combine to have the data that we need. So really, big data working with machine learning like hand in hand if we have a lot of data. So I mean, the way to retrieve the data is important too. I mean, you have like a ton of gigabyte data, but it takes like 2 hours to load it. So then what's the point, right? We need to be like quick, instant. So those technology will help us on that. So this basically, those technology is kind of like related together. That pretty much, yeah. So hopefully my goal is to review what is the machine learning problem. So when we see a problem, we gotta ask the question like, is that problem can be solved by machine learning? If we say yes, then we started like hiring a team to work on that. Like what kind of team we are hiring for? Obviously, we need a lead developer, we need a business owner, we need a data scientist, we need a R developer or Python developer. I don't need C# developer right now. So So we built a team, and then we started to collect the data, or we buy the data from somewhere. We need to think about data. How do we process the data? Where is the raw data? Or we can contract with Verizon to buy the data. Obviously, they're confidential. Well, if my company already have a ton of data, right, then I can utilize those data. Then think about data, think about process the data. Well, also need to learn about the capability of the algorithm that I'm going to use. So problem statement, identify the problem, categorize it in the classification, regressions, clustering, or recommendation, like what kind of like machine learning problems. And then pick the algorithm, and then prepare the data, combine it, test it, deploy it. So we understand the ML problem. We know how to solve the problems. We know what to do when we face that issue. Thank you very much. Do we have any questions?